Hey everyone, this is a video on Riemann sums and specifically calculating them using the TI-84 calculator. So right now what I'm going to do is this one right here, number 2 from the handout we were working on before. And we just want to find this L5 and R5 for f of x is 2 minus absolute value of x on this interval -2 to 5. So the first thing I'm going to do is go ahead and draw out my number line, and we're going to start right here at 2. We're going to end over here at 5, and we just want to break it up into 5 sections. So say 1, 2, 3, 4, 5, and ideally these would be equal. Obviously I'm off a bit, but that's okay. We'll go ahead and calculate our delta x as our b minus a, so in this case 5 minus -2 divided by our n, which in this case is 5, so L5 and R5 is going to be the same for both, so that's going to give us 5 minus -2 is 7 divided by 5. And you can use the fractions if you want, or if you want you can change that to 1.4. As long as this isn't like a repeating decimal where it's going to get rounding errors, that's fine if you just want to use the decimal. So I'm just going to use those. So we got 2, or actually -2, and then we're going to go up to 1.4. So add 1.4, that'll take us to -0.6. Add 1.4 again, that'll take us to 0.8. Add 1.4 again, I think that's 2.2. And then 1.4 one more time, looks like 3.6. And it doesn't hurt to just double check. The last 1.4 would indeed take us to 5. So those are 4 numbers, -2, -0.6, 0.8, 2.2, 3.6, and 5. The most important ones are going to be your beginning, your end, and these two right here, the next to last and the one next to the first. So those we'll use when we calculate these out with the calculator. Just real quick, I'm going to change colors here, and we'll kind of highlight what's going on. So if I'm doing a left-hand sum, then I'm using these guys right here. So -2, -0.6, 0.8, 2.2, and 3.6. Those are the left sides of all these intervals. And this is going to be where I want to start. This is going to be where I want to stop if I'm doing this left-hand sum with 5 subdivisions. So I'm going to start at -2, going to end at 3.6. On the other hand, if I am doing a right-hand sum, then I'm going to not start here, but I am going to start right here on the right side. So we're going to go there, 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 and there, and then the last one is that end point. So this is going to be my start this time. So I'm not going to use this first point, and I am going to use this last point at the end. So this is if I'm doing a right-hand sum, 5 divisions. So that's just to kind of illustrate what we're going to enter on the calculator, where you want to start, where you want to stop, depending on if it's a left or a right sum. You are going to need these numbers. You won't necessarily need these middle ones when you're entering stuff in, but you do want to make sure you have this next to the first and this next to the last handy. All right, so let's go ahead and head over to the calculator, and we'll go ahead and show you what we're going to do. So we're going to enter a sequence of numbers, and then we're going to sum up that sequence. So I'm going to go to second stat, so it says list right there, and I'm going to scroll over to ops. This will give us our sequence. Before I put that in, scroll one more over at math, number 5 again, the sum. So that's what we want to do. So we want to take a sum. So that's our sigma notation. So sum of a sequence. And let's go ahead and do second list And then we're going to go to this ops and then sequence again. Right there, down there is number 5. So I'm just going to scroll down number 5, hit enter. And we need an expression, a variable, a start, an end, a step, and then we'll just paste that in. If you're not getting this menu, I'll show you what you should type in a little bit. So just hang with me as we do this part. Just real quick, the expression. This is a cause of a lot of mistakes. So I just want to point out what we're doing there. So I'm going to change back over to the purple. So what we are adding, right, is the sum of our function f of x times our delta x. And this times delta x part right here, this is the cause of a lot of mistakes. So when we enter our function, we're going to put in our 2 minus absolute value of x, but then you don't want to forget to multiply by this delta x, this 1.4. So let's go ahead and do that on the calculator, and we'll see what we get. So I'm going to put in my parenthesis 2 minus absolute value of x. If you're not familiar with the absolute values in the math, then scroll over to num, right there, ABS, absolute value of x, and we'll close that off and then times 1.4. So this is my function and then times my delta x. All right, variable, that's just going to be x. We're going to start for our left sum at -2, and we're going to end, remember, at that next to last point. So not the 5, but the 3.6. And then step size for this one was 1.4. And then scroll down to paste and hit enter. And it'll paste it all in. Technically, you need like another parenthesis at the end, but it'll do it if you don't put it in. So we get 1.12. So that will be the left sum 5 subdivisions. Now, if you don't have that menu that pops up, let me go ahead and address that real quick. So I'm going to change this in my mode to classic, and I'm going to hit second enter, and that will give us everything we just typed in. So if you are in the old calculators that don't have the nice menus that pop up on some of these things, it's okay. It'll still do it. Just hit sum sequence like we talked about before. So that second list and then the number 5 for sum, the other number 5 for sequence. Type in your function. It won't bring up a menu. You just type it in with the parentheses just like you would normally do, times the 0.4. So your function, your delta x, this is the variable you're using, the x. Your start, -2. Your stop, 3.6. And then your step size, or your delta x, which is 1.4. So function times delta x, variable, start, stop, and then step. So that's it. And hit enter, and it'll give you the same thing that's right there. So 1.12. Now, if I want to do a right-hand sum, we'll do that in a second. Let me go ahead and just record that 1.12. So our L5 is equal to 1.12. So that is one of our answers. All right, let's go ahead and do R5. So now we're going to start at -0.6, and we're going to go all the way to 5. Everything else, notice, is the same. The delta x is still 1.4 because I'm still using 5 subdivisions. The function's still the same. We're just starting at a different place and ending at a different place for those rectangle heights. So all I have to do is hit second, enter. It gives me all the same stuff, and I just need to change where we're going to start. So rather than -2, we're going to start at negative. So I'm going to insert 0.8. Actually, it was 0.6, -0.6. And we're going to stop at the very end, 5. So delete those. Our step size is still the same, so that's all I got to change, that start and that stop, and now I have a right-hand sum. So hit enter, and there's our right-hand sum, -3.08. So I'll go ahead and record that as well. We got our right sum, 5 subdivisions is negative 3.08. So that's it. All right. So whenever you're doing these with either left or right sum, that's kind of the idea. The midpoints don't work quite as well on the calculator. I would recommend just going through those by hand. But you definitely can get a little bit faster with the left and right sum on these guys. Technically, midpoints you could do if you wanted to just say shift this over half a step and go from half of in between that first and second point, and then the next to last and the last point. That would work, same step size, but does take a little bit more calculation on that. Might be worth it if it's like 10 subdivisions, something like that. So anyway, that's left and right hand sums on the TI-84. There should be another video where I introduce how to do this in Desmos as well, just in case you want to try a different tool, but that's it for this time.